was old. Willy Wonka. Willy Wonka. All right. Not Bob the Builder. Nope. All right. We're finishing up with the most important identity in trig. This identity is the basis for all the other ones. All right, yeah. So it has something to do with what's a squared plus b squared? Is equal to c squared, right? A squared plus b squared is equal to c squared. X squared plus y squared equals r squared. In the unit circle, what is r? The radius, which is 1, right? So 1 squared is 1. What does x represent? Sine or cosine? What is it? Cosine. Cosine, right? And then y is the sine. So x squared plus y squared also means cosine squared plus sine squared. And that'll always equal 1. So repeat after me. Sine squared plus cosine squared is 1. Sine squared plus cosine squared equals 1. That's it. That is trig right there. That's it. Here we go. Let me take a second to calibrate it. It's like the best formula ever. Okay. Ready? Okay. The identity that I just described to you is called the Pythagorean identity because it comes from the Pythagorean theorem. Exactly. Here we go. The biggest one, and this is the one that you put a box around and put smiley faces all over it because that's like the one all of this comes from. Yeah. Right? Here we go. Is sine squared plus cosine squared equals 1? Again, with the proof. We know that x squared plus y squared has to equal r squared. True? Okay. And again, x is the cosine, so basically they're saying the cosine squared plus the sine squared equals r squared. R is always 1 on the unit circle. Hello? Right? When you write the squares for sine and cosine, you put it between the sine and the angle. Okay? So in other words, you could also say cosine squared plus sine squared is equal to 1. And then, of course, if you use the good old commutative property, this is the same thing as sine squared plus cosine squared equals 1. So commutative property, you can switch it around. It's all good. Which means that at the same angle, no matter what angle it is, as long as you're doing the sine and cosine from the same angle, sine squared plus cosine squared from that angle will always equal 1. It's a good day. Okay? All right. Here we go. The next identity is tan squared plus 1 is equal to secant squared. What? What? All right, here we go. Yeah. This one comes from this one. So here's what happened, right? Okay. Secant is the reciprocal of what? Cosine. So let's take that original equation. Sine squared plus cosine squared is equal to 1, right? If you divide everything by cosine squared, that's a squared, right? If you divide everything by cosine squared, what's sine over cosine? You're almost like cryptos? Oh, my goodness. I'm sorry, I heard it. Tangent! Sine over cosine is tangent. Yes, Miss Paige, because it's y over x. So y over x is tangent, and since it's squared, it's just tangent squared. Yay? What's the number divided by itself? Is equal to? What's 1? 1 over cosine is secant. We learned that yesterday with the reciprocal identities. So this is just secant squared. right? So like I'm trying to tell you, everything goes back to that original equation. P.S. What you guys did right now is called a proof. Yes, like in geometry when you had to do proofs, there are trig proofs. They're so much more fun though. So much more fun. Yes. Yes. All right. Here we go. Notice another form of this. Okay. Another form of this same proof, if you subtract the tangent or you subtract the 1, let's say you want to know what tangent is, you can also go tangent squared is equal to secant squared minus 1. All you did was subtract the 1 from the other side, right? Or you can also go, if you keep the 1, you can go 1 is equal to secant squared minus tangent squared. Do you see how it's the same formula? I'm just moving stuff around. Yay? The main one, though, is in the blue. Tangent squared plus 1 equals secant squared. You have to be able to recognize the different variations of it. It's not that bad. I promise. I promise. Okay. For that last one, it's the same proof. But instead of equaling secant squared, it's going to equal cosecant squared. Because instead of dividing by cosine, you divide by sine, right? Okay. If you divide this by sine squared, you get 1. What's cosine over sine? Cot. Yeah, so cotan squared, and then 1 divided by sine is cosecant. Cosecant. So that's why that proof is the way it is. I'm not going to do the proof for you because we just kind of verbally did it. But that's another variation of the same formula. Yay? Okay. Again, these are called the Pythagorean identities. Yes. Right? The main one, though, the main one, where it all comes from, the parent function, I should say, or the parent equation is that one. Man, she's making a big deal out of that. Well, it's because I like to eat at Tropical Smoothie Cafe. No? All right. Tan is sine over cosine. Tropical Smoothie Cafe. Oh, she's so corny. What are you going to do? Right? Okay. The other quotient identity is just the reciprocal of it. It's pretty easy. What is the other one? What do you think? Cosine over... Just switch it. Almost good. What's 1 over tan? Cotangent. Very good. Exactly. So just flip it around. Cosine over sine is cotangent. And I have nothing special for that, so I'm sorry. Cat's crazy sister. All right, there it is. No. Cheesecake, chocolate, scrumptious. I watch a lot of Sesame Street, and so they, scrumptious was the word of the day once. Yeah. What? You mean Count Von Count from Sesame Street? No. Count Dracula? Okay. All right, here we go. I don't know what's going on. All right. I think it's just, two examples. Here's one. Okay. Now, Eddie, did you say word problem? Yes. Here's the deal. The word problem, you have to map it out. So this is where it's important to go ahead and draw out the picture. Okay. Here we go. Anna. Here we go. Suppose an angle is in quadrant 3. Start there. All right. So the angle is in quadrant 3. So you draw your picture. This is your angle. Okay? Okay. And tangent is 8 over 5. Well, we know tangent is what over what? Y over x. Thanks, Donnie. So that means the y is 8 and the x has to be 5. All right, but look at the picture. If this is 5 and this is 8, it's on the third quadrant, so they cannot be positive. Yeah. Look over here, right? So here's the point, right? So if it's on the left, we know this has to be a negative 5. And if it's down, it's negative 8. Well, what's a negative divided by negative? Positive. That's why, all students take calculus, the tan's positive in the third quadrant. Just watch out. That's why we have to picture it, because the sign is actually different than what's given. I know, right? I know. What are we missing? Which one? R. Here we go. We know r squared is equal to x squared plus y squared. So negative 5 squared plus 8, negative 8 squared. 25 plus 64 is it 89? Oh, that's so good. It's so good. Yay. Is there a square root of 89? Not really. No. So if r squared is 89, that means r is equal to the square root of 89. Actually, it's plus or minus the square root of 89, but we know that r is always positive. So this finishes the picture at 89. Yay? From this, now we can complete the picture. First of all, if we know 10 is 8 over 5, cotangent should be pretty easy. Oh my gosh, Paige is 5 over 8. Yeah, that's easy. That's easy. Is it you? Was it you, Thomas? Are you okay? Okay, flip the tangent. That's the easiest one to find is cotangent. Yay? Okay, here we go. So cotangent was easy. Now let's go ahead and do, I don't know. Here we go. Sine. Negative 8 over square root of 89. We will clean that up in a little bit. We'll clean that up in a little bit. Yeah. Yeah. Aw, shucks. Here we go. We did sine, and now we're going to do cosine. Negative 5 over the square root of 89. Yay. Okay. Cosecant. Sorry. Yeah. Ooh. There it is. Okay. I hear you, Max. Is the square root of 89 over negative 8. Very good. And then, what are we missing? Secant is square root of 89 over negative 5. All right. We have two things that we need to clean up because they have the square root at the bottom. Remember, just multiply the top and bottom. So without me writing it out, what would it be? Over. Yeah, you just take it out of the house. You take it out of the house and put it upstairs. And all right. And the second one would be 89 over 89, and everything is clean. It's clean. It's good, right? So mapping out the quadrant, the triangle, where is that? Finds everything. It finds everything. Yay? Okay. Back page? To the back page. Here we go. All right. Oh, there's 3 examples. 3 examples. Ha, ha, ha. All right. The clues. So here's the deal. We only have to find cosine and tangent, and we're given this sign. I know, right? It's not bad. Okay. All right. Let's use our handy-dandy identities. So one way you could do it is drawing it out. That's good. Another way you could do it is doing the identities. So really quick. This thing says sine is positive or negative? Negative. And cosine is positive. What quadrant are you in? Fourth quadrant. She's good. She's good. Yeah, you're in quadrant 4. Right? Because cosine is positive and then sine is negative. So you have to be in quadrant 4. Okay. Yay? All right. Here we go. We need to find cosine. Yeah? You can, being in quadrant 4, you just have to take into account your sines, but we'll figure that out at the end. To find cosine, there is an equation that has sine and cosine in it. What's my favorite equation? Exactly. So another way you can solve this, Ms. Page, you can go back and do the drawing it out if you want to as well. Because I'm just showing you a different way to do it. Okay, so using the formulas that I gave you, we know that sine squared plus cosine squared is equal to 1. Yes? Yeah? Okay. We can go with it. Okay. I'll take you on this journey. Where we go, we don't know. Here we go. Negative square root of 2 over 3 squared is the sine. True? Plus cosine squared is equal to 1. Yay? Okay. The square of negative 2 over 3 is? It's not 2 over 6. It's not negative either. It's 2 over 9. It's 2 over 9. That's right. The square of 2 is 2, right? That just takes square root. The negative is gone. This will be 9 plus cosine squared is equal to 1. All right. Okay. Now, no me gusta la fractions. No, I don't like fractions. So the way you get rid of it is, here's what you do. Just multiply everything by the denominator. And what that does is, when you multiply it to here, it cancels the 9, so you just get 2. Yeah, exactly. You have to multiply the 9 to everything, though. So it'll be plus 9 cosine squared is equal to 9. Is good? Okay. So, yes, love? No, good? Okay. All right. So subtracting the 2 to the other side, you get 9 cosine squared is equal to 7. I know I'm making you religious. I am. All right. And then dividing by 9, you get cosine squared is equal to 7 over 9. True? Okay. All right. To get the square out, square root both sides. And that solves for cosine, doesn't it? Okay. Well, can you take the square root of 7? Nope. Can you take the square root of 9? Yeah. 3. Now, the answer is either plus or minus. Which one is it? Is it the positive or the negative? Positive. Why?
Because it says cosine is greater than 0.
Exactly. And we're in quadrant 4. We're in quadrant 4. So your answer has to be the positive of it. Okay. So we found one answer. Found cosine. Sweet. Okay. Well, if the question wants to know cosine and tangent, and we have sine and cosine, what formula would you use? R squared has tangent in it. Look at the front. Look at the front page. Which formula has tangent, sine, and cosine in it?
Sine over cosine.
Yes. Right? We know that sine over cosine is equal to tangent. Yeah. So if you just fill it in, it's good to go. Here's the deal. I love me some fractions because it's just like a mind game. So sine is negative root 2 over 3, and cosine we just found out was positive 7 over 3, right? what happens is, since the denominators are both 3, according to keep, change, flip, they just cancel out. Is that too much? Is that good? Yeah. So now we have root 2 over root 7. Can't keep it like that, though. That is a negative. Thank you, sir. There you go. All right. Yes, no, maybe the 3's cancel out because keep, change, flip, the 3 will cancel out. Yeah. I tried to save a step. I'll write it out. It's good? Yeah, a couple times. It's okay. It's okay. Oh. Yes, Thomas! Get rid of that square root of 7. So multiply top and bottom by root 7. So what do we have at the top? 14 over 7 is the tan of theta. Now check the sign. In the fourth quadrant, is tangent positive or negative? Negative. You did it right. We did it right. Yay, us! Yeah. Now, again, you could have gone back and drawn out the picture. If that is your favorite way to do it, do it. I'm just trying to give you another option. Okay? So let's take a look at the last one. Yay? All right. Paige, you get to pick. Do you want to draw out the triangle or do you want to use the formulas? What was your favorite way? You want to see a picture? We need a picture. Okay, let's do the picture then. Yay? What quadrant are we in? It says. Right. We're in quadrant 2. Thank you, Jesus. Everything's easy. Here we go. We're in quadrant 2. Didn't have to guess that one. Go ahead and draw your angle in quadrant 2, and then we'll figure everything out. Okay? All right. Cosine is negative 7 over 25. Cosine is what over what? Yep. That's the x. That's the r. So the x is 7, and the r is 25. But wait. One of them must be negative. 7. The 7. This is a good way, right? Like showing the picture. I like that too. All right. So to find the y, right? To find the y, it would go r squared is equal to x squared plus y squared. So would you agree that r squared minus x squared is y squared? Right? Just go backwards. Okay? So on your calculator, you're just doing 25 squared minus negative 7 squared. What is it? 674. And does it square root? It does not. 674 is it, right? Did we all agree with 674? It's okay. Where's my... I lost it. Oh, yes. No, I had it. Where's my... It doesn't square root, but it is 674, correct? Okay. All right. If it doesn't square root, where did it go? Oh, there it is. Okay. I just want to make sure it was in fact. I didn't write anything wrong, did I? Actually, I got 576. Did I write something wrong? You got 576. Yeah. Is it 576 or 674? Yeah. Yeah, so when you square it, put parentheses around the negative square it and then square it first. Yay? So it's not 674. It is 576. 76. And the square root of 576 is 24. But is it positive or negative 24? It's positive 24. Yeah, it's positive 24. Yes, love? Yes, absolutely. Let me see how you typed it in. Okay, put the square on the outside. Parentheses, -7, then square on the outside. Okay? Okay. All right, so as you can see, by drawing out the triangle, now you can just grab it. You don't even have to worry about, like making up fractions or anything like that. All you have to do is pull it out. So cotangent is what over what? Hello? Yes, sir. All right. So we know the cotangent at theta is going to be the x over y. So that is -7 over 24. Good. And then it wanted the cosecant, which is r over y. You're correct. The r is 25 over 24. And that's it. Okay. So again, I didn't mean to confuse you by that middle problem. Put a star next to example 6, right? Example 6 could have been solved the other way as well. I just want to show you one way to use the formulas and one way to use it by just drawing the graph. Pick your favorite way and get good at it. That's it. I'm not going to look for a certain method. Just pick your favorite one and get really good at it. Yay? Okay. When you get done with your homework today, what are you supposed to do with it? Keep it, exactly. Keep it and turn it in tomorrow with the homework quiz. Ole? Ole! Okay, good job, everyone. Woo!